welcome back to mobile application development. I'm going to do a little bit on OkayMon here today. I'm not really targeting finishing it or anything as a goal because most of this application is just mundane making of random cards, which I don't think would be very interesting to most people. But I'm going to just keep on showing off a few cool features. I showed off fragments the other day. Kind of hand waved around a lot of the cool stuff you can do with fragments. Just remember, fragments are like a mini activity. So you can do almost anything you could do in an activity. They're more lightweight and they can be packed inside of other activities very easily, as we've seen, which means that you can create a little snippet of UI, a little collection of UI, and shove it in wherever you want. So anywhere you see like a box, like let's say in your Google News feed or something, that it's split up into boxes with stuff in them, a little description, the three dots to look at details and stuff like that. Those are all probably fragments. And so a lot of you are making applications that like list things, like there was someone making a recipe tracker. A recipe tracker probably is going to rely on fragments a bit for different components. You might have a fragment for like the ingredient, and it has a picture, a description, the quantity, something like that. Generally, you don't want to use them too much for collecting user input aside from just clicking on it or maybe opening a menu, because if you have like an edit text in one fragment and another edit text in another and you have to link it all together, it becomes tedious. Probably better to just make a new activity in that case. But yeah, those of you guys who are making like list-based things, consider fragments for some of your UI elements at least. And then some people entertain the idea of doing networking or doing some kind of internet-enabled portion. And I just want to show you that it's not that hard to do, and I can get you a server somewhere. They're, not expensive. I can plug a Raspberry Pi in somewhere for you if you just want to test it out, or you can do it on your own network, whatever you want to do. So let's do a quick little client-server interaction in OkayMon. And we'll just basically come up with a way to transmit what card the player has played to the server, and the server will just, I don't know, play a random card back or something. I don't know. Doesn't matter. We're not actually going to manage the state too much. And I'm going to take a poll and see what everybody wants to do for the rest of the day beyond that. So after the networking part, do you want to see more OkayMon logic, game logic, or do you want to talk about your project with me in Discord? Alright, I still haven't gotten an idea from some of you. Just a reminder that the first checkpoint is due in less than 9 days now, and you do need to have something approaching functioning minimum product at that point. So make sure you've got something. I've given you a fair amount of code to borrow from, but I haven't had any real questions yet. So if you get stuck or you want to know how to implement something, let me know and I'll go over that instead. Alright, then we'll just go with OkayMon the whole time. Alright, so first I've set up a little server. Let's go through it and see how it works. This is just something I copied real quick from the network class. So creates a new server object, which takes us to the server object. Now this is just a simple TCP connection listener. If you have not taken 328, or you took 328 but you don't remember how threading works, we got some threading here, but not the complicated kind. Basically, we've got a thread that listens for inbound connections. It's packed inside of a runnable, declared it anonymously just for brevity. And you take a poll and see if people remember how threads work. I guess I'll say learned how threads work. I'll give you a not really option if you want to be non-committal. So this listens on a port. I set it to listen on port 6112, which is an arbitrary port that I picked. It doesn't matter. You pick any port you want. While true, it attempts to create a new TCP connection for anybody who tries to connect to it. That's what this server.accept line does. If it creates a new TCP connection, it prints out that it created one, and then it builds a worker to handle that connection. Now the worker runs inside of its own thread as well, so each worker on the server gets its own thread. This is a less common approach today than it once was, to give a separate thread for every individual user, but it's still definitely a common way to do it. So when a TCP worker is built, takes in the socket, starts its thread. The thread just listens on the socket for input, and then calls the receive input method when it gets some. The receive input method receives a string from the socket and then prints it to the console along with the source IP, the port, and then the IP and port of this machine, which are going to be the same in this case because I'm going to be running the server on the same machine. So all told, this server can handle connections from as many users as the machine can handle, and it will receive input from all of them and print it to the console. So it doesn't do much. That's very interesting. Now we need to handle the client end in our OkayMon application. And I guess let me just shamelessly copy that too. I got a good one here. I'll use that. TCP client. This lets me send random string data. I don't even need this keyboard entry one, so I'll probably get rid of that too. Okay, so I'm going to add another class to my Android implementation. We'll call this TCP client. I'll copy my TCP client source. And hopefully Android Studio still has print writer, as that's kind of an old class from the Java library. Hey, good, we've got it. And we've got socket. Yep. And we need unknown host exception and IO exception. And then I'm going to comment out get input for now. Okay. So instead of get input, I'm going to send arbitrary data. Yep, that'll do. I'll just send arbitrary data in the socket. So we've created a new outbound socket, and then we are creating a print writer to shove text into the socket. We will shove text into the socket with out.write. We put a new line character at the end just for convenience, and then we flush it, which sends the data along. So this is not a networking class, so I'm not going to go into too much detail on any of that stuff, but you can imagine that it's just a pipe that sends text on one end and receives it at the other, and just hand wave around the rest of the networking stuff, because it'll be good enough for almost all of your purposes. So your goal whenever you want to send something over the network in this class is going to be to convert it into either an array of bytes or into text. Then you can push it into your networking pipe, receive it on the other end, and do whatever you need to do with it on the server. Now, if you want to have some sort of persistent experience, you want to save the user's data and stuff, then the server is going to have to write to the disk somewhere. It's going to have either a database, which is a little bit harder. I can show you how to do that too. Or it's going to just save to like a text file or something, which you should know how to do. You should know how to save to a text file at this point. Android lets me use a lambda. Woo! Look how much shorter that was and how much less easy that is to understand. Let's do it. Why not? All right. let's make this a singleton too, for the sake of... Because I think you will only ever have one client at a time talking to the server. But you have to have the destination in the port in mind. Well, the destination for now is always going to be 127.0.0, and actually, because we're only going to have one server in mind, that's always going to be the destination. So I'll leave myself a to-do here, change the destination IP to the server's actual IP, and then I'll leave you guys a note here. Note 127.0.0.1 is localhost, which sends data back to your own machine. So if you're running the server on your own machine to test it, as I am here, then localhost works perfectly. Okay, that makes it close enough to a singleton. What, oh, really? Okay. That's an interesting optimization that Android Studio figured out. I prefer this syntax usually. I don't know why I wrote it the other way, but good for them. That was actually pretty cool. Okay. And this needs to be static. And that needs to be static for singletoning. Alright, where do we actually want to send stuff from? Well, I can do it here in the gameplay activity. I had some buttons that I set up, and I did like a listener forum, so let's send data there. Okay, so I'm going to create a TCP client up here. Okay, I guess I might as well get my first run out of the day. Run of the day out of the way. Run of the day out of the way. Make sure nothing crashes at this point. We're going to run into some difficulties here, I remember for sure, because Android is not happy about you doing networking stuff anymore. They want you to do networking through their very specific walled garden. They want you to do networking through Firebase and the different things that they've got. They don't want you to do networking through your own custom implementation. So, of course, there's difficulties to overcome there. And doing regular unencrypted networking will get your app marked as dangerous on the Play Store, which is also very annoying. Okay. Well, it didn't crash, so that is a good start. Alright, continuing, we're going to send something via our client. Oh, and when it started up, did we get any kind of connection? No. So I guess we'll see what happened there. Let's see. Alright. Let's try to send something over the network and see how badly it fails. So instead of just logging the button click, I'm going to try to send it over the network. I'm going to send the ID plus v.getID. So I'm sending the ID of the button that you pressed over the network. Did I put the wrong port? (6112) 6112. No, I'm good. So, when I tried to hit a button, I forgot to pull it up on my screen, but when I tried to hit a button, it crashed. Let's run it again and I'll show you. Boop. Bye-bye. All right, let's see what it did. A null object reference. TCP client dot send data 41. So we're looking at out.write, and this part didn't happen here. Okay. So it looks like it's not properly creating the thread that handles everything, or the thread is being killed. So let's see if we can figure out why that might be. I'll tag these as TCP client and say thread created. Okay, and we have a system error going on there. So it's an error in the run. Android's not going to let me open a thread this easily, is it? That's going to be a real shame. All this extra stuff I'm going to need to do. Oop, don't know why I'm getting rid of that. So we don't actually get to this point here. Let's go see what else we can do. Now, what if I do TCP client dot get instance every time I want to send the data instead of creating one like that? I don't think this is going to make any difference. Nope. Same issue, null object reference, because it isn't actually creating that. Ah, there we go, there's a problem. Socket failed. E-access, permission denied. Ah. Alright, let's practice our Googling skills here today. This is what I knew we would run into eventually. Alright. Calls gives me this exception. Here is my manifest file, blah, blah, blah. Alright, try it with uses permission, Android permission dot internet. This guy gets it. Alright, so I'm going to go to my manifest, and I'm going to find my permissions. Where are those guys at? Well, I don't have any yet, so where do I put them? Let's try putting them up here. I think this is a good place. See if we still get that exception. I don't see it yet, so that's a good sign. Let's push the button. Oh, crashed. Still have a null object reference. Let's see what it decided to tell me now. I don't see anything yet. Failed to connect to, connection refused. So, failed to connect to 127.0.0.0.6112. This guy is running, but my connection was refused. I'm stupid, and I didn't think this through. Okay. My phone is no longer my computer. So I'm a moron. I can't use 127.0.0.1 because that's the IP. I forgot this was running on my phone, guys. That's how dumb I am. So obviously I need to get my computer's IP address on the local area network here. So let's, we're looking for, whatever. What's my Mac going to do for anybody? Nothing. All right, so we're looking for my computer's address, the one that's running the server, which locally is 192.168.0.135. So 192.168.0.135. All right. Of course, if you got yourself a server up and running, you'd want the IP address of that server instead, and actually you'd want a DNS level Now I got a different thing again. Alright, still null object exception. Let's see what it's telling me now. I have no useful error messages yet. Did I establish the connection? I did, and then of course it died. Let's do something about this whole thing here. The spammingness. I don't do that anymore. Socket.close. Once receive input fails. Break. Yeah, hopefully that works. All right. And back here in Android Studio, launch it again. And let's see what I get. So it's waiting for connections. It'll be waiting until I push the button. Push the button, I get a bunch of networking spam. So it did at least attempt to send something. And let's go back to my studio and see what happened. Well, it killed off my thread again. But I did get the thread created this time, so that's a good start. Alright, let's go back to the client. And I think the problem is that I'm attempting to call send data before the thread is properly created. So this needs to completely execute before send data calls, otherwise we have problems. So let's go with the old way that I had to do this. That way it gets created at the beginning. Whoops, gotta restart this guy. See if I was quick enough. Alright, so it accepted a new connection. When I hit the button, it crashed, but that's an improvement that it didn't just spam me nonstop. So now we've got a network on main thread exception, so you are not allowed to do networking on the main thread. Darn. Okay, well, that's a struggle, isn't it? And yet another fun feature of Android. So the close out of everything. The call to the client.sendData happens here in onClick, right? And the method that gets executed is there then, okay? And that executes on the main thread, on the thread that runs the UI too, which is unfortunately a no-no in the Android world. So there are a couple of stupid hacks that you can do to fix this. The easiest is just to do this, and it's probably a bad idea, but it's good enough. This will definitely cause a thread fault in bulk, but it's the easiest way to do it for testing purposes. So I'm going to do a boolean, has data. We can set this to public. Yeah, let's set the private. Boolean has data. And then we'll do a void. Did I already call it send data? Yes, I did. Okay. So if has data, then we're going to write has data to private string data, we're going to write the data to our socket and then flush it. Now this can happen on the thread. So we're going to have this run forever, while true. Okay, so we will have a loop forever inside of the thread. Anytime that has data flag gets set to true, it'll push something out. So void schedule transmission, string to send. It's going to say that data equals to send, and then it's going to set as data equal to true, and then it will send out when the thread is next available. Schedules the specified data to be sent out when this thread, when the network thread is next available. So ideally you want to buffer the stuff that you're going to send out. You have multiple things in the queue, because in this case, if you want to send more than one thing at once and the thread hasn't finished yet, it will just fail because it'll overwrite the thing you wanted to send before. But the advantage is that this is no longer trying to do networking. Now we're going to, rather than send it, we are scheduling it to be sent, and then the network thread will pick it up and actually do the sending. So the connection still died, and this is still not properly closing the socket. Definitely should have fixed this implementation better. What do I get here? So we'll just break when you get a null. That's fine for me. Okie doke. Now start the server again, and start the Android guy again. And there's OkayMon, and there's the button, and ooh, it didn't crash, so that's pretty good. Alright, so I pushed the button, didn't crash. Let's go back here, and it's sending the stupid thing repeatedly over and over again, because I, like a dummy, forgot to set the to send back to false after a transmission. So this creates a race condition, because if you try to update data from the main thread while this is updating data, then you've obviously made a mistake. So these need to be synchronized correctly and yada yada yada, but whatever. We could just try to add the keyword synchronized to them in order to solve the thread fault and all that stuff, but you know, yeah, it's fine. What's the worst that can happen? Really, it will require quite a bit of effort to do the synchronization properly down the road, but at this junction, it's not that important. So, and it's not that hard to. I can show you how to do it if it becomes a problem for your application, if you end up running into this kind of thread faulting. The occasional lost piece of data is usually not a tragedy anyway. All right, so we accepted a new connection. I'll pull that up alongside Eclipse, and we can watch it transmit the button ID. So there's the button 1, there's button 2, there's button 3, there's button 4, there's button 5. So it's getting info from the buttons as we want to. So there we go, different buttons coming in. Cool. Okay, so I'll leave the server up and see what happens when the connection dies. Did I actually get the server to properly close its sockets? Oh, maybe I did. Lovely. Alright, let's try again. If I launch again, will it accept the connection again? Yes, it will. Alright, so it accepted a new connection. Then I can transmit new buttons by pushing it. Okay, so that's the basic client and server relationship. So now Let's say that this is the server that's responsible for maintaining the match. So you would need to do a few things on the server's end in addition to this simple stuff. You're going to need to maintain the game's state on the server's end, and it's going to have to talk back to the clients and tell them what state they're in. It's going to need to maintain what cards are on the field and all of that stuff. So it's going to be pretty complicated by the end of it. So let's see. Let's say you have so many cards in play. I guess I should make like a list of cards or something. Let's call it card glossary. Is it Uri or Ari? Ari, I think. A card glossary. This is going to contain all the possible cards that there are in OkayMon. Maintains a list of all the possible cards in OkayMon. Cards equals new card. And let's say there's, I don't know, I think they specified 80 or something possible cards in OkayMon. So cards of 0 will be a new card called, what are the different card types? There's beach, waterfall, and jungle. I think there's also supposed to be like banana types and stuff like that. You know, actually these card types here, I'm missing more from the, it's rough. Missing more from the specifications. So the types here are supposed to be in a hierarchy according to the spec that the students wrote. So let's do that. We've got a creature card that's supposed to extend card. And this is all from their spec here. Okay. Create a constructor, and then the creature card is the one that has the different types. And so that one takes a card type. Okay, and there's also supposed to be a banana card. Banana. That also extends card. Okay, so there's creatures, there's bananas. Those all have a cost and upkeep, a name, and then a UI component that I haven't yet specified, and probably won't for this part because I spent enough on the front end already. Then we're going to go to the card glossary and make some new cards. So cards of 0 will be a new banana. What do you need for the banana again? I've already forgotten. Cost, upkeep, name, card UI. 5 banana. We'll just make a new one for now. Oh. Can't do that in the abyss there. Now this can be a singleton or it can be an all static class. I think that's probably acceptable too. Yeah, I'm happy with it. I guess I can do a instance thing again. Just to follow in Android's footsteps, since there are so many of these. So many singletons all over the place. Hooray, another one. It's just singletons everywhere. Okay, so that's banana. Bananas should cost 0. They have an upkeep of some number of energy. per turn. Oh yeah, negative upkeeps give you energy. Bananas give you energy. Alright, so we got bananas. Let's call them red bananas. Red banana gives you 2 energy. And then call it super banana gives you 3 energy. I don't know what a super banana is, but cool. And then we gotta put some creature cards in there. I guess I should specify integers for all of these. Gross. Public static final int. Banana. Red banana. Super banana. Bonus points if you catch me spelling banana wrong. B-A-N-A-N-A-S. Alright, now to come up with some creatures. If you've got any ideas for OkayMon creatures, hit me up in either chat. Let's call it Giant Bug. This is the first one. I don't even think Jamaica has that many insects, but Giant Bug has no upkeep. Giant Bug. I need to specify a type too, because Giant Bug is a creature. And the types are beach, waterfall, jungle, and I think like rock or something. The 4 types. It's like a rock, paper, scissors thing. Maybe it's just beach, waterfall, and rock. I mean, jungle's not in there. I don't want to go look at their specs, so it's fine. Creature has the card type as its 3rd argument. After name. Okay, so it's creature dot card type dot what are bugs? Bugs are clearly right. You know what? I'm bringing back the jungle type. It just makes sense to me for insects, even though I don't think Jamaica has jungles. It just makes sense to me. Creature dot card type dot jungle. I'm not hearing any dope creature ideas in either chat for OkayMon. This team needs your help. They don't have any cool ideas either. Call it Metal Drummer. Metal Drummer's a good one. It's got 2 cost. Oh man, I forgot to do like attack and stuff for these two, so now I gotta make the constructor even longer. The Metal Drummer obviously lives on the beach. Yeah, I gotta add attack and stuff to the creature. So I got like attack and health. It's attack and health. So Giant Bug has 1/1. Metal Drummer, a little more durable. Maybe a little stronger. 2 health. Or 2 attack. Yeah. Hit some of this metal drum. What's a rock type creature? Let's just call it Jagged Rock. That's like a creature. Jagged Rock's definitely 2 cost. It's got a lot of health, but only 1 attack. Jagged Rock. Metal Drummer. Rock type. I need a waterfall type creature too. What's a waterfall type creature that's Jamaica themed? creative here. I'll call it small waterfall. And apparently some of these cards are supposed to be more effective against others, so that's part of the game too, but I'm gonna gloss over that for now. Small waterfall has an upkeep because it's an expensive card. It's got tons of health. Small waterfall is a powerful card. If you can play big waterfall, you are set. Okay, so I created a few cards. I added them to the glossary. Now, I'm going to reference these cards by their ID, basically, and I'll add a method here, return clone. And then it's going to say the index of the one that you want. And this is going to clone a card for you from the index. So this will return a copy of a card. Return a copy of a card from the glossary by index. So this will return new, and then it will search the cards of I for everything. Cards of I. And we're going to need to add a clone method to our card probably. So public void clone. Public card clone. Returns a copy of this card. Return new card with the cost, upkeep, name, and UI. That's given here. Okay, and then we want the customized version for creature and beach. So it returns a new creature with the cost, upkeep, attack, health, etc. Attack, health, name, type, UI. And likewise for banana. Well, actually, banana can just use the one that it inherits from card because banana doesn't have anything special. So cards of I dot clone. Whoops. Okay, there we go. So that returns a clone of the card. It'll be a problem when I'm cloning creatures because of the way I did it. I made everything descend from card, which means that you lose some information when you clone a creature. So I'll have to deal with that inheritance way later, but it's fine for now. Unless I want to deal with it now. Think about that. So, going back to your 129, what's the problem here? Well, I specified the card glossary. Everything is cards. Everything just inherits from the hierarchy. But I have creatures here that have extra features. They have attack and health that cards don't have, right? So if I return a clone of the card, I lose the attack and the health if it was a creature, because I'm just storing it as a card instead. Right, so I can give it access to the attack and the health through another class. I can give it properties through another class. I can have a card properties class attached to card, or I can add those fields to card in order to make it so that the creature just inherits from it directly. But then I lose access to the type, so I'd have to add type back to card. That's a problem. I can make a separate glossary of the cards for the creatures, so I can do that. I could do something like creatures, creature, but now I have two different arrays to keep track of, right? So no good solutions here. All of them are going to take a minute to implement, so we're just going to move on for now. And then, you know what, this is a good challenge for the 217 team. If they're watching, they get to fix this. They get to fix, because they made this inheritance hierarchy. Now they get to fix it. All right, so returns a clone of the card that you want from the glossary that lets you do whatever you want with it. Okay. Okay, so I want to be able to tell the server which card you played. So first, going back to my player, we've got this deck variable. We never actually made a player or anything. I also don't have anything to manage the game state or anything. We had our initial hand, we were supposed to shuffle it. All this different stuff that we were supposed to do. So I want to distribute each player a deck. In the final version of the game, you would be able to build your deck, but in the testing version, I want to just give you a test deck. So I'm going to write a method that gives you a test deck. We'll call it void generate test deck. It generates a deck randomly from the available cards used for testing. Okay, so deck equals, and did I already specify a size for the deck? No, I guess I didn't. Only if you take an array of cards already, which we're gonna create a new method that doesn't. That uses generate test deck instead. Okay, and we'll write code here. Creates a player with a randomly generated test deck used for testing only. Okay. So deck is a new deck. Let's call it 40 cards. Sorry, new deck of cards. We'll call it 40 cards. We'll fill the first, let's say, 20 with bananas. It's supposed to have half bananas in your deck or something. So we'll fill the first half of your deck with bananas. How many banana cards are there? Just 3 banana cards. So, card glossary. Ah, I forgot to add a get instance to it. Didn't I? Oh, I did. I just forgot to make it static. So, card glossary dot get instance dot, and we're going to do some cloning. What did I call this thing? Return clone. That's a stupid name. Let's call it get clone. No, I don't even need the instance. I'll just go get clone, and I'll call it on rand. Okay, and then for the rest of the deck, we're going to pick from the available creatures. I've added 1, 2, 3, 4 here, so I'll just pick between those 4 for now. So there's 4 to choose from, and we want to skip the first 3 indices. Yeah, 4 to choose from. Skip the first 3 indices. Okay. So that generates your test deck of cards. And then let's print it all out at the end, just so we can see what kind of deck you got. So I is 0, I is less than deck.length, and we're going to print out log.d player's deck plus deck of I dot name. Ah, right, 2 arguments. We'll print out I plus thingy space and then deck of I dot name. Okay, so I never actually made players or anything. I don't have like an object that tracks the match state or anything. I think it's probably best to have one, and in fact that was one of the better choices that the 270 team made, was they had a class that manages the match. The problem is that they had 2 player objects on theirs, and one of our player objects is going to be the networked thing. Only one person is local, so player, I guess we can call this, we'll just call it player. We understand that this is the local player, the person who's playing the game. Here is a new player. The local player on this machine. And then there might be like a player other, and this might be the player on the other end of the network. But you can't access this object because this player is going to live solely on the server. They don't have, you can't look at their properties and everything. The only communication you're going to have with them is when the server tells you which card they played. So this is probably not going to be a thing, but we'll see. Okay, and this will handle different things like whose turn it is, so we'll have probably something like int state, and we'll call this like something. We'll have different possible states, like static state. Player 1 turn is 0, but it's a card game, so it's more complicated than that. We probably have things like the upkeep phase and the draw phase and all this different stuff, and this should order when the person draws from their deck and all these different things. So it's going to be really complicated at the end of the day, but I'm going to try to hand wave around that because we've only got like 15 minutes and I want to do some more cool networking stuff. So public match. Let's do the setting up of the player here. And then we'll do more logic there later. Okay, so going back to my gameplay activity at last, I'm going to create a new match because the gameplay activity represents a single match. And I don't have to create it here. I could create it elsewhere and tie them together. But this is the main activity. This is, you enter it here. So I'm going to enter it here, create the TCP client, create the match. Everything will happen here in the main thread at the beginning of the activity, and then all that cool stuff will happen later. All right, so we've created a new match. By creating a new match, we've created a new player. This creates a new player using the randomly generated test deck, so I should probably document that over here in match 2. Creates a new match with a randomly generated test deck for the local player. I ought to actually create a constructor for the proper version, which takes an array of cards. Now in the proper version, this array of cards is going to be loaded from the local file system or from the server or wherever, where you retrieve the array of cards that the player actually owns, the one that's registered to their deck. So you'll have an activity where they build their deck. Once they're done building their deck, it'll save to the file system, or it'll save to the server, or wherever it saves. And then when they start a match, it has to load their deck from that place. It'll get passed into here. It'll end up in the player. Everything's lovely, but that's way beyond what we're doing today. Unless somebody's interested in doing like file I/O and loading and saving to the disk, then we'll do that next time too. All right. You know, after each player shuffles, they ought to draw their initial hand too. So I'm going to add that to both constructors as well. Okay, we'll add that to both players' constructors as well. And then in our gameplay activity, It's going to print out the deck after we get started here. Let's see if everything's hunky-dory. As it creates a match, it's going to make a player. It should print out their deck. Let's see, we got a unable to invoke on a null reference. Let's figure out where that happened. Looks like I probably accessed an index in deck that doesn't exist. Let's make sure I made all my indexes correctly. 0, 1, 2, 3. Oh, I never called this method anywhere. Whoopsie. Alright, so let's make this not static anymore. And let's call it properly. The card's not static either. And then when you call it, it's got to be called through the instance. That's the advantage of the singleton. It forces the instantiation of the card glossary because this constructor always has to execute. You create the object at least the one time, and that forces everything to get instantiated at the very least. Still got the same problem though. Card glossary. Still no. Am I creating a new one? Yes, I am. Why is it telling me that this method is never used? That doesn't make much sense to me. It's very clearly being used there, Android Studio. Is it using the wrong one? Write a comment for it, returns the active instance of card glossary, makes one if one exist. Alright. Now it thinks that it's linked. Maybe that was the problem. It hadn't successfully linked itself yet. Nope. Okay. Back to player. That's the, okay, cool, that's the documentation that I get. It's still not returning the right card there. So let's see what index it's failing at. So it fails at 6. Oh. Yep. That'd make a lot of sense. It fails at 6. Stupid. I had the index, I had multiple 4s. Okay, so there's the person's deck. It's made of a bunch of bananas, and then they get some random cards in there. Cool. Alright, I'm going to erase that printout functionality from wherever I put it. I think it was here. And I'm going to actually put it at the end here and verify that their deck is properly shuffled. And then I'm going to print out their hand at the end too, and verify that they have a hand. So we'll see what's in their deck, and we'll see what's in their hand. Alright. So some reading from the hand failed, which means that the draw initial hand failed. Right, because the hand actually holds more cards than you draw in the first place, so I need to do a null check whenever I look at the hand, because some of the cards in the hand are going to be null. In the deck, I don't remember what I did, honestly. I think I decided that some can be null or something. I think I have a top of deck variable that tracks. Alright, so there's the player's deck of 40 cards. They do look like they've been mixed up to me. They're at least semi-random. And then there's the player's hand. They got Jagged Rock, Small Waterfall, Super Banana, Giant Bug, blah blah. Okay, and I have one more change to make it shuffle a little better. I'll crank up the number of cards randomized per shuffle. Let's send the player's initial hand to the server. Let's see how we would do that. Okay, so we're just going to send the player's initial hand to the server. And I'm going to make a method for debugging purposes. We'll call this like void print deck and hand. Just so that I don't delete this stuff when I might need it down the road later for debugging. Okay, so I want to send the player's info to the server. Void send deck to send hand to server. Do you want to trust the client's interpretation of what cards are in their deck? Absolutely not. In fact, all of this information should ideally be on the server only. The players shouldn't maintain their own deck. They shouldn't maintain their own hand. The only information that they should have is what the server tells it to do. So this is already a bad model to have. But again, I am following to an extent what the students specified in their class diagram. So of course the reason that you don't want to do this is because you could easily cheat by just inserting whatever cards you want into your deck by modifying the code here or modifying the memory of this application. So it leaves a big hole for cheating where you can just insert whatever cards into your hand or deck that you please. So really all of this stuff should happen on the server's end. My server unfortunately is incredibly dumb. So how do I want to send the cards over to the server when all I can send are strings? Well, what I probably want to do is I want to send each card's ID from the glossary, and then the server can recreate it on its end. Or I can send the names or something, but the best thing to do is probably to send the IDs from the glossary. But I don't have glossary IDs for any of my cards saved anywhere. They're not saved on the card. So what I probably want to do is I want to add another field to my card. Or I guess this is at least the easiest way to do it. This will be a private int. It'll be the glossary ID of this card. And the glossary ID is yet another argument that you're going to have to specify. I'll add a getter for it. Sometimes Android Studio is so clever, and sometimes it's not. So after the UI, so that works for those. And every card is going to be registered when it creates it in the glossary with its card ID. Where's my banana? I just like to add it to banana. Okay, so this one gets registered to 0. This one gets registered to 1. This one gets registered to 2. I get the feeling that I've probably overcomplicated this for the most part. small waterfall. Alright, cool. So now all of them remember their own IDs. That means if I want to send all of the different cards in a player's hand, then all I have to do is loop through the hand. I think I've already done this before, so I'll just copy the loop in. And I want to send those all along, so I'll do the TCP client. I'll get its instance, and I'll schedule a transmission of all of the cards in the player's hand. So if hand's not equal to null, string to send equals blah blah blah. This is horribly inefficient because we're doing string concatenation and everything, but that's fine. So string to send equals hand of I dot get glossary ID plus, and then we'll do a little comma between them to transmit them to the server. Okay, so we'll send the player's hand to the server initially. So we'll transmit the player's entire hand to the server. I'll do it at the end of both constructors. Alright, so if I run this now, on my server end, I'll see a connection be accepted. Okay, and then I just saw the number 4, which means that I messed this up and forgot to put plus equals. Wump wump. Did I? Yep. Okay. Trying that again. So on the server's end, I now see 42243. So coming in as cards. Right. Then you can still send IDs of buttons over to the server. Okay. And I want to fix this a little bit so that the very last one doesn't have a comma at the end of it. So how do I trim just the comma off the end? Well, the jankiest way to do it is, of course, to take the substring from 0 to the length minus 2. What did I do here? I trimmed the last 2 characters, from the end. Yep. Not a good way to do it. But it's quick. And there we go. Now I don't have that annoying comma at the end. Cool. And, you know, I might even want to add something like to stop it, but I guess the stop condition is just that there's no more commas at the end, so that's fine. All right, so I want to regenerate. I want to display on the server's end what cards are actually in the user's hand. I've transmitted the glossary IDs, so I want the server, in the last 5 minutes I have here, to echo back what cards you actually have. So let's move these 3 classes over to the server too. I mean, you will probably have to do this. You'll have to keep these 3 classes updated on these servers. Now luckily both ends are written in Java, right? So I have to stop my server in order to make changes to it. Let me pull my card glossary, card, banana, and creature in. Since I wrote both ends in Java, although you certainly don't have to, I'm able to very quickly get everything copied over. The only thing that has to change is you got to get rid of some of that maybe banana or Android specific stuff. And I don't need the card UI on the server's end necessarily, so I could just keep it for simplicity, but I certainly don't need it, and it'll probably be blank on all of these. And now just to get rid of some of these Android specific things. Wrong package. And this is going to do nothing on the server end. The server doesn't do anything with the UI. So that gets them all copied over correctly. Okay, and I have them all. Any clips here? I don't think I had any errors, so that's good. And then I want, whenever the worker receives a line like this, it's going to register it as a hand update. And so I'm going to add a little bit more to my transmission. I'm going to update it to include the word hand at the beginning. So it'll know that it's a hand transmission. It'll be a hand and then a comma. In fact, I don't even need the commas. I just need the spaces. We'll see how that works in a bit. Alright, so I'm just getting the hand at the end. Alright, so let's go with a public void process hand. Process received hand. This will probably update some sort of state that the server has, and I don't have time to do. And we want to do if line dot, there's a begins with, I think. No, I'll just use contains. If line dot contains hand, then process received hand string contents. So we want to process it, print it out to the console. We want to print out all the different cards that you had. So first I'm going to trim it. We want to trim it starting from the first space, which indicates the end of the part that says hand. So it says hand, and then a space, and then the rest of it. Right? So printing it up to there. I'll print that out just to make sure that that verifies. After trim. Okay. And then I'll build the scanner and invoke it on what's left of contents. I never know which one I want. While scan dot as next. Card index equals scan dot next int. And then we'll print that card name out. So that would be card glossary dot get instance dot cards of card index dot get name. End of hand. Okay, let's see if that works. So I'm going to start the server, then start the Android application. And I now have Metal Drummer, Red Banana, Super Waterfall, Smart Waterfall. And you can see how I trimmed the hand off at the beginning there. And if you look in the Android applications stuff, well, the hand that it registered was, I removed it from being printed, so you'll just have to take my word for it that they're the same. So I was able to send the hand over to the server. Now the server can decide what to do with it, and you can use the same kind of behavior to send played cards back and forth. All right, that's all the time we have for today. Next class, I'm going to bug you about how you're doing with your application, so make sure you've got something to show me next time, anything at all, and I'm going to talk to all of you about it. If you haven't posted your idea, post it, and let me look it over, make sure you're good for the checkpoint coming up, And yeah, make sure that you're working on it. Don't be lazy. Don't not work on it, or it's gonna really come back and bite you if you have to crunch it at the end of the semester. So make progress on your app. Let me know what you want to learn more about, and I will keep trying to show you stuff that's interesting. Okay, see you next time.